Module 1, Section 9, Objective 5, putting it all together. And Objective 5 is solving application problems using multiple operations of whole numbers. Okay, so we're talking about real-life situations, story problems, using more than one operation. Okay, so we're solving each problem. You're using the polio process to solve it and seeing what we get. Okay, so remember we have understand it, build a plan, execute, and review. Okay, so John has a large Blu-ray collection. His entertainment center has 9 shelves, and each shelf can hold 35 Blu-rays. If each shelf is full, how many Blu-rays are in his collection? If each Blu-ray is worth $21, what is the total value of John's collection? Okay, so we read through the whole thing. Do we understand it? Kinda, maybe. Okay, what I would do as part of understanding is draw it out. Okay, so we have 9 shelves. Let's actually draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9 shelves. And on each shelf we have 35. I'm not going to draw 35, but we could, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. There we go. So my shelves weren't big enough, right? But the idea is there's 35 on each shelf. So there's 35 here, 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 all the way down, right? And then when we're done with that, they are $21 each. And we want to see how much it costs. Okay, so part of the understanding is to take a guess. Is it going to be kind of expensive? I would say so. But let's see. Let's come up with some kind of a guess here. So 9 is kind of almost to 10, right? And 10 times 35 is 350. So this is my guess. So 350 approximately Blu-rays on the shelf. And now we're going to times it by $21. So I'm just going to times it by 20. Okay, so 35 times 2 is 70, and then 2 more zeros. So it's about $7,000 worth of Blu-rays. Okay, so I'm going to put that up here because I need to erase it and have room to do my problem. Now you shouldn't erase yours. Just write it out and leave it there, and you have more space than I do. Okay. Now I left this part here because this is what we need to figure out. Okay, we could add all of these 35s up, couldn't we? But that would be repetitive addition, which basically means multiply, doesn't it? Okay, so we're going to do 35 times 9. Okay, now I can erase those. So 35 times 9. Set it up like this, right? So we get 45, carry 4. 9 times 3 is 21, add 4. 9 times 3 is 27, sorry. Add 4 is 31. And we're having some problems here. There we go. So 315. So that's how many Blu-rays he has. Okay, let's see if I can move this so we can, yep, there we go. So we're going to do that part first, and now we're going to figure out how much his collection costs. Okay, so we have 315 of them at $21 each. So we're going to multiply, aren't we? Another repeated addition. So we could add $21 315 times. I don't want to do that, so let's multiply. So times 21. So 1 times 5 is 5, 1 times 1 is 1, 1 times 3 is 3. Now, second row, we're going to move over. 2 times 5 is 10. 2 times 1 is 2, add 1 is 3. and 2 times 3 is 6. Add those up. So we have $6,615. And that was pretty close. Okay, so I'd say that it makes sense. It's a pretty expensive collection when you have that many, right? So I'd say we did pretty well. All right, G. Victor has a part-time job that pays him $1,450 a month. His rent is $575. His car payment is $200. And his share of the utilities is $57. How much money does Victor have left after paying these monthly bills? Okay, that makes sense, I think. So, understanding the problem, so I understand that he makes, let's just do a circle graph, there we go. He makes this much. Okay, so this is $1,450. Okay, his rent is this much. I'm just totally making it up, I'm guessing. $200 is his car. Don't you wish, right? And then 57 is utilities. So we want to see what that is. So what I'm going to do is add all of these together first and then subtract it from $1,450. Okay? So that's kind of part of my B for building my plan, but I had to kind of see what I was doing in order to make my estimate. Okay? So I want to add these, no, not that one, these three up. So I'm just going to do front end rounding. So I have about 600, 260. So 860 approximately. And I want to subtract it from 1450. Just to make it round and easier to do, what if I made it 1460? That's close, right? So now when I subtract, I get an even 600. Okay, so that's my estimate right there. Let's see how close I am. But we know he's going to have money left, right? Because these numbers don't add up to be more than 1450. Okay, so let's see what we've got. Let's add those up exactly. So 575, 257. So 5 plus 7 is 12. 1 plus 7 is 8, and 5 is 13. 1 and 5 is 6, plus 2 more is 8. Okay, so he has to pay, he pays out $832. Okay, and we said it was about 860, so that's not too bad. Okay, now, if he gets 1,450, and he pays out 832, we're going to have to subtract it, aren't we? So let's borrow here. 10 minus 2 is 8. 4 minus 3 is 1. Now here we have 14 minus 8 is 6. So he has $618 left. And we said it was going to be around 600. So I'd say we did pretty well. Did it make sense? Does it fit the problem? Is there an easier way? I really do think we did okay. Okay, a youth group of 15 people need $12,000 to go on a service trip. If they make $9,000 through a series of fundraisers, how much does each member of the group now owe? How much did each member of the group originally owe? All right, let's figure this one out. Okay, so we have this whole amount of money that they need to have is $12,000. And there are 15 people. Okay, so we'd have to have 15 little wedges, right? And we'll not go any further because mine looks really bad. So we have 15 of these. Okay, that's the original. Okay, so how much did each member of the group originally owe? That's that one. But now they made 9,000 through fundraisers. So this isn't 12,000 anymore. If we made 9,000, this is going to be less, isn't it? So now we need to figure out how much is left and divide that by 15. Okay? So we have two answers. All right, so does it matter which one we do first? Nope. Let's do the first question that they ask first, though. So if they make 9,000, how much does each member owe now? Okay, so we started with a 12, and they made 9,000. So we want to see what they have left. So they have $3,000 left. And now that's going to be divided by 15. Okay, so 3,000 divided by 15. 15 doesn't go in 3, but it goes into 30 twice, evenly. Okay, so then we just need placeholders here. So $200 is how much each person needs after their fundraisers. Okay, now the original was 12,000, and there were 15 people. 15 doesn't go into 1, and it doesn't go into 12, but it does go into 120. Okay, how many times? I'll tell you. 8. 8 times 15 is exactly 120. And I said that wrong, didn't I? 120, no and. Okay, so now we have zeros, and that's it. Okay, so originally everybody owed $800, and then they did fundraisers as a group and got to split it, so now they each only owe $200. So is there an easier way of doing that? There's probably a better way of drawing it, but I think we did the rest pretty well. Okay, nice typo in this one. Okay, Energy Solutions Arena. Yeah, there we go. Can hold 20,000 spectators. Recently, 16,491 people bought tickets for an event. But on the day of the event, there were 2,184 tickets left in will call. So these are tickets paid for but never picked up. So how many seats were empty? Oh, interesting. Okay, I'm going to draw it out this way. So this is my arena. Okay, so panoramic view, I guess, if you want to call it that. So if this holds 20,000, whoops. Nope, I'm going to have to slide it back down, sorry. So if it holds 20,000 people, and 16,491 bought tickets. So let's say it was this full. So 20,000 is all the way full. Okay, so I keep having technical issues here, sorry. Okay, so 16,491 is from here to here. Okay, so these were never purchased. Okay, but now the day of the event, there were 2,184 tickets in will call. So these are ones that have already been paid for that the people didn't show up for. Okay, so that means we're going to go backwards from the line that we had that was the purchased line, 2,184 tickets to here. So this amount here is how many people actually showed. Is that what they're asking for? So this is actual people at Energy Solutions. They want to know how many seats were empty. So how do I find that? You're going to take the original 2,000 and subtract the actual number of people. Okay, so we're going to do 20,000, sorry, minus that number is going to equal empty seats. Okay, so at the beginning it was just these that were empty, but now these are also empty because those people never came. They bought their tickets and never came. Okay, what are we going to do? I'm going to start with that part. Okay, so 20,000 minus 16,491. What does that give us? So 20,000 minus 16,491. Okay, so this, wow, okay, 2,000 becomes 199 and 10. 10 minus 1 is 9, 9 minus 9 is 0, 9 minus 4 is 5, 9 minus 6 is 3, and 1 minus 1 is 0. So this 3,509 is 3,509 is this portion right there. Okay, and now that I'm getting into this, I'm going to change the way I'm doing it. Okay, so we understood the problem, we thought, we built a plan, and I'm in the process of executing my plan, and I see a better plan. So I'm going to change it right now and then execute that new one before I review my answer. So what I see is I don't need this number, because if I have this number I just found, if I can now find this number, which is given to me, all I have to do is add these two up, don't I? And I won't need this number over here at all. So 3,509 seats that were never purchased, they never got tickets, and the 2,184 seats that people bought tickets and never showed up. Okay, so 9 plus 4 is 13. 1 plus 0 plus 8 is 9. 5 plus 1 is 6. 3 plus 2 is 5. Okay, so that number right there is that many seats were empty that night. Seems like quite a bit, right? 5,693 seats were empty. All right, C. So, understanding the problem, let's read through it. It says, find the total cost of 3 sweaters at $38 each and 5 shirts at $25 each. So we want the total cost. We're going to add them all up. Okay, so we could go 38, 38, 38, and 25 5 times, right? This is what the register does. This is what your receipt might look like. Each individual sweater and each individual shirt added up. Okay, however, repeated addition, we know there are shortcuts. Okay, so we're going to do 3 sweaters at $38 and 5 shirts at $25. Add them up. Okay, so I understand what I need to do, and I've kind of built a plan, right? But part of my understanding, let's come up with an estimate. So 3 sweaters at 38, this is close to 40. So let's say that's about $120. Now 5 shirts at 25. If you round it up, we get $30. 5 times 30 is 150. So $270. Okay, that is an estimate, and that's fine. The second one, you could round it to 20. You could actually just multiply 25, but that's not estimating, is it? That's not rounding. That's figuring it out exactly, and we don't want to do that. So let's just leave it at the 270. Okay, so my plan is to figure out how much the sweaters cost, figure out how much the shirts cost, and add the two answers. Okay, so sweaters. 38 times 3. So we get 24, carry 2. 3 times 3 is 9, add 2 is 11. So we have $114 for sweaters. Now let's do the shirts. So 25 times 5. 5 times 5 is 25. 5 times 2 is 10. Add 2 is 12. So we have $125 for shirts. Okay, so now let's do 114 and add 125 and see what we get. 4 plus 5 is 9. 1 plus 2 is 3. 1 plus 1 is 2. So $239 is how much we paid. Were we close? I think we're close enough because we rounded up quite a ways, didn't we, to go from 25 to 30. Was there a faster way? I think we did it the fastest way. If we would have done it this way, we could have found a faster way. Okay, next one. Sarah is saving money for college. She makes an initial deposit of $400, then deposits $150 a month, each month for 3 years. How much is the account after 3 years? And they probably should put ignore interest, right? Okay, so we start with $400. And then there's 150, 150, 150, 150, 150. How many times? And by the time we're done, we want to know how much total was there. Okay? That is a horrible diagram. But you get the idea, right? Okay, so that's me understanding the problem. Okay. Now, estimate. This one's going to be kind of hard to estimate. So let's build our plan first, and then we can estimate. So we'll come back to the U part. So start with 400. And then we're going to add 3 years worth of $150 a month. How many months in a year? 12. So 3 years is 3 times 12, or 36 months. So we're going to have 36 150s. And we're going to add that on to 400. Okay? So that's my plan. Now let's estimate it, just for practice. Okay? So this is already estimated, so we're going to leave that. And I keep moving the screen, I'm sorry. So 400 plus, now let's say this is 40 times, round it up to 200. So this would be 400, order of operations, we need to multiply first. So 4 times 2 is 8, and then the 3 zeros. So 8,400. And that's going to be high because I rounded this up and I rounded that up. So our answer should be lower than 8,400. Okay, so let's see how we get estimate. Okay, order of operations. We're going to do multiply first, aren't we? Okay, so 400 add, Now, off to the side here, let's do 150 times 36. 6 times 0 is 0. 6 times 5 is 30. 6 times 1 is 6. Add 3 is 9. Second row, you move over 1. So 3 times 0 is 0. 3 times 5 is 15. 3 times 1 is 3. Add 1 is 4. So 0, 0, 14, and 5. So 5,400 goes here. And now we want to add these two together. So 5,400 add 400. Could you have just added it here? Sure. The problem is I don't like to do that because when I come back to check my work, I don't know what I've done when I just have one ginormous problem instead of a whole bunch of separate ones. Okay, so we're adding here at 0, 0, 8, 5. So $5,800 after putting $150 into the account every month for 3 years, starting with $400. Okay, so our estimate was $8,400. It's way high, wasn't it? Okay, but I don't think it's completely out of the ballpark, so I'm going to say we're still okay. Okay, so reviewing. Was there a shorter way? I don't know. I think the estimate was a little bit off, but that's not what we're reviewing. Does it seem logical that after 3 years you'd have that much money? And it does. It adds up pretty fast, doesn't it? Okay, Gabriel has two $20 bills in his wallet. He buys 6 party favors for his daughter's birthday party. Each party favor was $3. How much money does he have left? Okay, so let's take a look at it. Let's understand what we have. Two $20 bills. So here's one, and here's another. And he buys 6 party favors. And each of those cost $3. And we want to take that out of the money that he has and see what he has left. Okay? All right, so what's our plan? Well, let's actually take a guess. Let's see if we have 6 at $3 each. With this one, it's kind of hard to guess and evaluate rather than actually just computing, isn't it? Okay. Is he going to have less than 40? Sure, because he's going to spend some of his $40 on those party favors, right? Is it going to use all of it? No. So let's just say our estimate is between 0 and 40. That's not too helpful, but it works. Okay. Estimating isn't always incredibly helpful. So let's take a look at this now. Okay, so if he has two $20 bills, he has $40, right? Or we could have done 20 times 2. And if the 6 party favors are $3 each, they cost $18. Can you see that we have to subtract those now? Because we want to take the 18 out of the 40. So 40 minus 18, you borrow. 10 minus 8 is 2. 3 minus 1 is also 2. So we have, oh, not 20, $22. Okay, you can think about it a different way. $18 is only one of the $20 bills, isn't it? With $2 left. So he still has one of the 20s, and then add $2, which is the 22. Edith can make 8 quilts with 24 yards of fabric. How many yards of fabric would she need to make 12 quilts? Okay, so, wow, let's find out. If she has all of this fabric, if you unroll a bolt of fabric, it's just going to be one long thing of fabric, right? And let's say that's 24 yards. Okay. And she can do 8. There we go. So we have 8. So how much is each one? And once we figure out how much each one is, because they're all going to be the same, we could times it by 12. Okay? So if we start with 24 and we have 8, aren't we dividing this by 8 to see how many each one is? And yep, we are. So we have 3 yards for each. So 3 added together 8 times would give you your 24. So instead of doing repeated addition, we're going to multiply. 8 times 3 is 24. Okay, so 3 yards per quilt. And now she's going to make 12. So 3 yards per quilt. God, and there are 12 quilts. So 3 times 12 is 36. So she would need 36 yards of fabric to make 12 quilts. And let me move it back so you can see it. Okay, Mark and Jared are 2 competitive brothers that decided to play basketball. There are 2-point and 3-point baskets. Mark's team scores 6 2-point baskets and 3 3-points. Jared's team scores 7 2-points and 2 3-points. Who won? And by how much? Okay, so let's take a look at it. We have Mark's team scores 6 2-point baskets and 3 3-point baskets. Okay, so 6 times 2. So they got 12 points off of those. And 3 times 3, which is 9 points off of those. Add these up. They made 21 points. Okay, now Jared's team, 7 2-point baskets and 2 3-point baskets. So 7 2-point gives you 14 points. And 2 3-points gives you 6 points. Add those up. And his team got 20 points. So whose team won, and by how much? So this would have been the blue team, which was Mark, by 1 point, right? And notice I didn't do Uber on that one, and I apologize. But this is kind of a really difficult one to do an estimate. So I didn't even worry about it. All right, K. A couple just finished remodeling their basement. One of the bedrooms measures 12 feet by 16 feet. The door into the room is 3 feet wide, while the door to the closet is 5 feet wide. How much wood baseboard did they need to buy to go around the entire room? Okay, since we're talking about all the way around the outside, the rim of the room is the perimeter, right? Okay, so I'm going to assume it's a rectangular room. We know that because 12 feet by 16 feet, right? So 12 feet here, 16 feet here. We're not going to multiply those because that's finding the area. We're not talking about carpet. We're talking about baseboard. And baseboard just goes all the way around it, right? Okay, there's a door into the room and there's a closet door. Do we care where they are? Nope, not at all. Okay, so I'm going to add a door into the room. Let's say it's right there. 3 feet, and a closet door, I don't know, maybe over here, that's 5 feet. Okay, so what do we have? If this is 3, that little mark means feet, right? and this is 5 feet. Okay, this is my understanding of the problem still. I'm still working on that one to figure out what I'm doing. Okay, so we could try to add all of this stuff up, but that might be kind of hard, trying to figure out this piece here and how much that is and how much this is. So instead, doesn't it make sense that we do exactly what I did? You take the entire rectangle and then you subtract out these two parts. I whited them out, but we could just subtract them. Okay, so let's find the perimeter first. So all the way around. So that would be 16 plus 12 plus 16 plus 12, right? Is there a shorter way of doing it? Maybe. Let's try it this way and see. 16 plus 12 is 28. And here's another 16 plus 12. I already know it's 28. Now 28 plus 28, or 28 times 2, right, is 56. So that whole room is 56 feet all the way around. But now I'm going to subtract the 3-foot door and the 5-foot door. Okay, so 56 minus 3 is 53. And now 53 minus 5 is 48. So they would need 48 feet to go all the way around the room. Okay, was there an easier way? Maybe. Okay, perimeter was a little long, but we got the answer right. So if you can come up with a shorter way of doing that, that's great. There are some formulas that, for example, 2 lengths plus 2 widths, or 2 times length plus width. Those are both maybe shortened versions of perimeter, but it would still be 56 feet all the way around. Okay? All right, last 2 problems. Here we go. One wall is going to get a new coat of paint. The wall has the dimensions below with 2 windows that are the same size in the middle that will not get painted. 1 gallon of paint covers approximately 350 square feet and costs $29. How much will it cost to paint the wall? Woohoo! Okay. So first of all, let's figure out how much paint we need. Okay. How much paint? Then we need to figure out how many gallons. And then we'll figure out the cost. Okay, multi-steps. Wow. Okay, how much paint? This is the area, isn't it? Okay, so I want the area because we want this whole part, not including the windows, right? Okay, so I'm going to find the area of the entire outside and subtract the windows. Okay, like we did on the baseboard on the problem before, we subtracted the doors. Okay, we're going to subtract windows this time. So the area is the entire wall minus windows. Okay, so the entire wall would be length times width minus one window is 5 times 3, and the other window is also 5 times 3. Okay, so 40 times 25. 5 times 0 is 0, 5 times 4 is 20. Move over 1. 2 times 0 is 0, 2 times 4 is 8. So 1,000. 1,000 minus 15 for one window and 15 for the other window. Okay, so do you agree then that these two 15s give you 30, right? So we're going to do 1,000 minus 30. So this is going to become 99 and 10. Oh, I don't have to do that, do I? Duh. Okay, so 0 minus 0 is 0. Now 100 minus 3 is 97. So this is 970 square feet. Okay, now 1 gallon of paint covers 350 square feet. So I want to figure out how many 350s there are in that. Okay, I'm going to slide it up. Okay, so I want to do 970 divided by 350. Whoa! Okay, so let's times it by 2 and by 3, just to double check. Okay, so 3 is too big. We have to use 2. Okay, so 2 goes here. And we have remainder 270. So what does this mean? Okay, in terms of how many gallons we need 2, but then we have a whole bunch of leftover. So we're going to need 1 more to cover the leftovers. So we need 3 gallons. So 3 gallons are needed. And they cost $29 each. So let's do 3 times 29. Three times 9 is 27. 3 times 2 is 6. Add 2 is 8. So it will cost $87 to do the entire wall. Is that something we could have estimated? Not really. You know, we could have estimated that it would have taken 3 gallons. I don't know if we could have estimated that or not, you know. If you do painting for a living, then maybe. Okay. All right, let's try this one. I'm going to give a space this way. All right, a gardener's trying to decide how much fertilizer to buy for his yard. His lot is in the shape of a rectangle and measures 90 feet by 120 feet. Okay, 90 feet by 120 feet. The house on the lot measures 45 feet by 65 feet. Okay, so there's a house on here, don't know where. Oh, that looks like a square. Let's not make it a square, shall we? Okay, house is 45 feet by 65 feet. How much area of the lot is not covered by the house? Okay, this one's actually easier than the last one. So we want to find this portion here, because we don't want to fertilize where the house is, right? We just want to fertilize everything else. Now this is assuming there's no driveway and all that, so we're making a lot of assumptions, but that's okay. So, do you agree that we're going to find the area of the outside and we're going to subtract the area of the house? It's like doing the area of the wall with the 2 windows. We're going to subtract them out. Okay? Because if I don't do the house, I don't want fertilizer for that part, so that's why I'm going to subtract it. Okay? So I want to do the entire lawn. Whoops, forgot my I. Entire lawn minus the house. Okay, so the entire lawn, this is area. So the area is length times width, and we have 120 times 90. And now the area of the house is another length times width, which is 66 times 45. Okay, just throwing something at you here. Length, width, length, width. It looks like these L's are the same and these W's are the same, possibly. Sometimes you will see, they're called subscripts, to identify the difference between one length and the other length. So, for example, they could have written that the length of the yard times the width of the yard minus the length of the house times the width of the house. So it makes your formula a little bit more complicated, but you know exactly what to substitute where. Okay, that's just an FYI. You don't need to know that for now. Okay, let's do 120 times 90. So 0 times everything is 0. Now let's move over 1. And we go 9 times 0 is 0. 9 times 2 is 18. 9 times 1 is 9. Add 1 is 10. Okay, now this is the long way. And I'll come back to that when we're doing the review. Okay? So 10,800. Technical issues today. 10,800 feet squared. Okay? Now we're going to minus the house. So 66 times 45. 5 times 6 is 30. Carry 3. 5 times 6 is 30. Add 3 is 33. Move over 1. 4 times 6 is 24. Carry 2 this time. 4 times 6 is 24. Add 2 is 26. Add, 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 add. Okay, so the area of the house is 2,970 square feet. Okay, so now I have to subtract those. So we have 10,800 minus 2,970. Okay, so 0 minus 0 is 0. 0 take away 7, can't do it, so we need to borrow. 10 take away 7 is 3. 7 take away 9, can't do it. Borrow again. 17 minus 9 is 8, and 9 minus 2 is 7. So what did we just find? 7,830 square feet, and this is the area of the lawn, because that's the entire lawn minus the area of the house, right? And how much area of the lot is not covered by the house? That's what we wanted. We wanted the lawn. So we're done. Okay, to make it as hard as the last problem, they'd probably want to know how many bags of fertilizer and how much the fertilizer cost. Okay? All right, so reviewing. And again, this was going to be a horrible one to estimate, so I didn't even worry about it. Is there an easier way? Yes. Right here. This was the long way, right? If you remember our zero and multiplying trick, and if you know your times tables. 12 times 8 is 108, and then 1, 2 zeros. Boom, boom. And that would have been a lot faster, wouldn't it? Okay, other than that, I think we did all right.